Hello, very good morning students. Am I audible? Am I audible? Okay, thank you. Okay students, so today we continue our lecture with Fourier series and today we are going to solve continuous example with the limit 0 to 2 pi. Okay, so let's start with the example, that is suppose your question is find Fourier series f of x is equal to x square in the interval 0 to 2 pi, and hence deduce that pi square by 12 is equal to 1 upon 1 square plus 1 upon 2 square. Sorry, this one is minus. So 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square plus up to so on. Okay. So this is your question. Your function is continuous in the interval 0 to 2 pi and you have to deduce this equation through your Fourier series for this function. So before start the solution of this Fourier series, I just want to recall the formula of the Fourier series. The formula of the Fourier series, that is f of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx plus bn sin nx, right? Now, the formula for a0, that is 1 by pi 0 to 2 pi f of x cos nx f of x dx, right? This is for a0. And the formula for an is 1 by pi 0 to 2 pi f of x cos nx dx. And the formula for bn is 1 by pi 0 to 2 pi f of x sin nx dx. This formula you have to remember. Okay, every time I will not return or I will not recall you this formula. Okay, so let's start with the solution. So for the solution of this question, our function is f of x is equal to x square. First we have to find the coefficient constant a0, then an, then bn, and all three values of a0, an and bn we have to substitute in our original formula for the Fourier series, that is a0 by 2, here summation n1 to infinity an cos nx and plus bn sin nx. So let's start the solution. Here for the solution, our function, what is our function? Our given function is x square, right? So let's start with the first coefficient constant a0, that is 1 by pi 0 to 2 pi f of x dx. Okay, so 1 by pi 0 to 2 pi f of x is x square. Our given function f of x is x square. So x square dx. So the integration of this x square is x cube by 3 and the limits are 0 to 2 pi. So if I keep 3 out of the bracket, that is 1 by 3 pi, and if I put my upper limit in this place of x, then I have here 8 pi cube. Eight pi cube minus 0. By students, one student have query, Mohammed roll number 74. Ma'am, x square is even, so can we write 2 integrate 0 to pi? Mohammed, no. Here, this function x square, see, we can convert any function into even and odd if our limits between minus L to L. Okay. Here our limits are what? 0 to 2 pi. If our limits are minus pi to pi, or minus 1 to 1, or minus 2 to 2, then and only then we can convert our any function into even or odd. Okay. So in this case we cannot convert our this function in even type. Okay. I think your doubt is clear now, right? So let's move ahead. So here, by substituting the upper limit 8 pi cube and by lower limit 0, because 0 cube is 0. So after simplification, the value of a0 is, pi will be cancelled. So 8 pi square by 3. Okay. So students, this is the value of a0. This is the value of a0. Now, for the value of an. So, the formula for an is equal to 1 by pi 0 to 2 pi f of x cos nx dx. So, 1 by pi, our f of x is x square. So, x square cos nx dx. Okay. So, in this case, x square is our u and cos nx is v. What is our u? U is x square and v is cos nx. So, we are applying the integration of u dot v. So, 1 by pi x square, keep it same. The integration of cos nx is sin nx upon n minus the derivative of this x square is 2x. Now the integration of this sin nx is what? Minus cos nx upon n square. Now plus the derivative of this u1, that is 2x. The derivative of 2x is 2. And the integration of this minus cos nx is minus sin nx upon n cube. Okay. And the limits are 0 to 2 pi. Devansh has any question? Ma'am, please show the side in which you solve for a0. Okay. See, this is a0, Devansh. What happened? Devarsh, sorry. What happened, Devarsh? Have you any doubt? Devarsh, have you any doubt? Okay. So, students, here our f of x is x square cos nx. We are doing the integration using u dot v formula, or we can say the Leibniz rule. Here x square, keep it same. The integration of cos nx is sin nx upon n minus the derivative of x square is 2x. Integration of sin nx is minus cos nx upon n square plus derivative of 2x is 2, and the integration of this minus cos nx upon n square is minus sin nx upon n cube. Okay. Now, if we put our upper limit in this integral, first 2 pi, this 2 pi square, that is 4 pi square, but the sine 2n pi, if I put here 2 pi, then I have sine 2n pi, and the value of sine 2n pi is 0. Okay, which we already discussed in our previous lecture. So please remember this value. The value of sine 2n pi is 0. So our first term is 0. Now for the second term, minus minus plus. If we put here 2 pi in the place of x, then we have 4 pi. Then cos 2n pi. Cos 2n pi is 1 upon n square minus, again, sin 2n pi is 0. So our third term will be 0. Minus if I put my lower limit, so 0 into sine 0, that is 0, plus again 0 into cos 0 is 1, but the 0 into cos 0, that is 0, minus sine 0 is also 0. So 1 by pi 4 pi upon n square. After simplification, the value of an, that is 4 upon n square. Okay, so this is the value of an. Yes. Now let's move for the value of bn. Have you any doubt for the value of an? If you have any doubt, please write in the chat box. Okay. Now let's move for the value of bn. 1 by pi 0 to 2 pi f of x sine nx dx, right? So 1 by pi 0 to 2 pi f of x is x square sine nx dx. After integration of x square sine nx, here again u is x square and v is sine nx, right? So x square keep it same. The integration of sine nx is minus cos nx upon n. We are applying Leibniz rule here. Minus 2x. The integration of minus cos nx is minus sine nx upon n square plus the derivative of 2x is 2 and the integration of this minus sign, that is minus minus plus cos nx upon n cube. Okay, and the limits are 0 to 2 pi. So 1 by pi, if I put my upper limit here, that is 4 pi square. Here cos 2n pi is 1, so minus 1 by n. Sin 2n pi is 0. So 0 into anything is 0. So our second term will be 0 plus 2 cos 2n pi is 1. So 1 upon n cube. So this is the value of the upper limit. Now for the lower limit, if I put here 0, so 0 into cos 0. Cos 0 is 1, but 0 into 1 is 0. So my first term will be 0 after putting the lower limit. Plus 0 into sine 0, sine 0, 0 into 0, so second term also 0, plus 2, here cos 0 is 1, so 1 upon n cube, right? Now, these are the value of the upper limit, these are the value of the lower limit, so 1 by pi, here minus 4 pi square upon n plus 2 upon n cube minus 2 upon n cube. Okay. So here both term will be cancelled and this pi also cancelled. So value of Bn is minus 4 pi by n, right? Minus 4 pi by n. So this is the value for Bn. So is there any doubt to any students up to the value of Bn? Okay. So let's move for the further solution. The formula is f of x is equal to a0 by 2 summation n 1 to infinity an cos nx plus bn sin nx, right? Now what is the value of a0? The value of a0 is 8 pi square by 3. Value of an is 4 upon n square and value of bn is minus 4 pi by n. So here if I put 8 pi square by 3, so 2 into 3 plus summation n 1 to infinity. Here the value of an, that is value of an is 4 upon n square cos nx plus summation n 1 to infinity. The value of bn is minus 4 pi by n into sin nx, right? Now, after simplification, here our function is what? F of x is x square, right? So this is x square. Here 4 pi square by 3. If I keep 4 as a constant, then summation n 1 to infinity cos nx upon n square minus 4 pi summation n 1 to infinity sin nx upon n, right? So I also represent, this is the Fourier series in the form of summation. So I also represent this Fourier series as if I start n with 1, 2, 3 up to infinity. If I put here 1, then my first term will be cos x upon 1 square. Then the next term is cos 2x upon 2 square. Then next one is cos 3x upon 3 square, like that. Minus 4 pi. If I start with the 1, that is sin x upon 1 plus sin 2x upon 2 plus sin 3x upon 3 plus up to so on. Students, both are Fourier series. This is in the form of summation and this one in the number of terms, right? So if our question is like that, find Fourier series of f of x is equal to x square. If our question is like that, find Fourier series of f of x is equal to x square, then this is our answer. You may write up to this term or this term as you wish. Both are same. But our question is find Fourier series and hence deduce that, okay? So we have to deduce this equation through our Fourier series. See carefully, our equation is 1 upon 1 square, 1 upon 2 square, upon 3 square, like that, okay? So we have to put the value here by putting x is equal to, see, we just need 1 upon 1 square, 1 upon 2 square, 1 upon 3 square, like that. We didn't need 1 by 1, 1 by 2, we don't need 1 by 3, right? So by putting x is equal to pi, our left hand side is x square, so that is pi square, right? Now x is equal to pi, so that is pi square. 4 pi square by 3, keep it same. 4 pi square by 3, keep it same. Plus 4. Plus 4. If I keep here pi, then cos pi is minus 1. Cos 2 pi is plus 1. Cos 3 pi is minus 1. So my answer will be cos pi is minus 1. So minus 1 upon 1 square. Cos 2 pi is plus 1. So 1 upon 2 square. Again cos 3 pi is minus 1. So minus 1 upon 3 square. Plus 1 upon 4 square. Like that. Right? And sin pi, sin 2 pi, sin 3 pi, all sin pi are 0. So the next all terms are 0. So pi square minus 4 pi square by 3 is equal to 4 minus 1 upon 1 square plus 1 upon 2 square minus 1 upon 3 square plus 1 upon 4 square, like that. So this is 3 pi square minus 4 pi square. So minus pi square by 3 into 4. So that is minus pi square by 12. And this one is minus 1 upon 1 square. So 1 upon 2 square minus 1 upon 3 square plus 1 upon 4 square minus up to so on. If I keep minus common from both the sides, then my answer will be pi square by 12, that is 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square. This. So this is what we want to prove. Okay. This one is what we want to prove through our Fourier series. Students, there is no specific rule for taking this x is equal to pi. You have to apply your logic that you have to decide that what you want to prove. You want to prove or you want to find the 1 upon 1 square, 1 upon 2 square, 1 upon 3 square, like that. So, according to your answer, okay, you have to decide what you have to take, what is the value you have to take of the x. It may be 0, it may be pi, it may be pi by 2, it may be pi by 6. Okay, so as you will Priyam sheet, how many marks for this question? Uh, Priyam, normally 6 to 7 marks, 6 marks, minimum 6 marks. Okay. So, this is the answer of your question. Have you any doubt? Have you any doubt, students? Okay. So, let's move with one more example. Okay. So, let's move with one more example. That is, find Fourier series for f of x is equal to pi minus x by 2 whole square in the interval 0 to 2 pi, right? So, it means our function is pi minus x by 2 whole square. So, we write our function, that is pi minus x by whole square by 4. Okay. And the formula of the Fourier series is f of x is equal to a0 by 2 summation n 1 to infinity an cos nx plus bn sin nx, right? So the first we start with the formula of a0, that is 1 by pi 0 to 2 pi f of x dx. Okay, so the 1 by pi 0 to 2 pi f of x is pi minus x whole square by 4. So if I keep this 4 out of the integral as it is a constant, so pi minus x whole square dx. Is there any doubt to any students? Okay, so 1 upon 4 pi. Now the integration of these pi minus x whole square is pi minus x whole cube upon minus 3. Okay. See, pi minus x whole cube upon 3, and by applying the differentiation of this x, that is minus 1. So upon minus 3, that is 0 to 2 pi. Now a0 is equal to 1 upon 4 pi. Minus 3 into 4, that is minus 1 upon 12 pi, right? Minus 1 upon 12 pi. Now if I put my upper limit, that is pi minus 2 pi. Students, be careful here. Pi minus 2 pi. So pi minus 2 pi means minus pi cube minus pi minus 0, that is just pi cube, right? So minus 1 upon 12 pi, this is minus pi cube, again minus pi cube, So this is minus 2 pi cube. So minus minus plus. So 2 pi cube upon 12 pi. So after simplification, my answer will be pi square by 6. Right. So this is my first value for the A0, that is pi square by 6. Now for the second value, and the second value is an. So the formula of an is 1 by pi 0 to 2 pi f of x cos nx dx, right? So 1 by pi 0 to 2 pi. As you know, f of x is pi minus x whole square upon 4. So I keep 4 here, and this one is pi minus x whole square cos nx dx. Students, again we are applying Leibniz rule, that is u dot v. Our u is pi minus x whole square and v is cos nx. So 1 upon 4 pi. See, keep u remain same, that is pi minus x whole square. The integration of cos nx is sin nx upon n minus the derivative of this pi minus x whole square is 2 pi minus x by applying chain rule minus 1, right? Minus 1. So this is the derivative of this one. Now the integration of sin nx is minus cos nx upon n square plus this 2 into minus 1, that is minus 2, and the derivative of pi minus x is minus 1. So minus 2 minus 1, and the integration of this term is minus sin nx upon n cube, and the limits are 0 to 2 pi. Students, be careful about this integration. Sometimes students making some sign mistake, they forgot to apply the chain rule. Okay, so please keep in mind this 1 upon 4 pi. After applying the upper limit, here sin 2n pi is 0. So our first term will be 0. Now this minus, minus and minus 3 times minus. So 2 pi minus 2 pi, that is pi minus 2 pi, that is minus pi. So I keep this 2, pi minus 2 pi is minus pi, and this cos n pi is, cos 2n pi is 1. So 1 upon n square, right? Again sin 2n pi is 0. So the third term will be 0. So this is the value of the upper limit. Now by substituting the lower limit here, sin 0 is 0. Now again minus 2, pi minus 0 is pi, cos 0 is 1, so 1 upon n square, and again sin 0 is 0, so the last term will be 0. So after simplification, 1 upon 4 pi, this is 2 pi upon n square, and this one is again minus minus plus 2 pi upon n square, right? So 1 upon 4 pi, and this is 4 pi upon n square. So after simplification, my answer for an is 1 upon, my answer for an is 1 upon n square, right? So this is the second value. Is there any doubt to any students till the value an? If you have any doubt, please write in the chat box, or you can raise your hand too. Okay, no one have any doubt. So we'll move for the next value of Bn, that is 1 by pi 0 to 2 pi f of x sin nx dx, right? Now the value of f of x is 1 by pi, 0 to 2 pi. This is pi, if I keep here 4, and pi minus x whole square sine nx dx, right? Now 1 upon 4 pi, again applying the Leibniz rule, pi minus x whole square, keep it same. The integration of this sine nx is minus cos nx upon n, minus the derivative of this pi minus x whole square is 2 pi minus x, 2 pi minus x, and after applying chain rule minus 1, and the integration of this minus cos nx is minus sine nx upon n square. Now the derivative of this term is 2 into minus 1, that is minus 2 into minus 1, and the integration of this minus sign is minus minus plus cos nx upon n cube. Okay, and the limits are 0 to 2 pi. So 1 upon 4 pi, after applying the upper limit, pi minus 2 pi, that is minus pi. So minus pi square, this minus cos 2n pi is 1, so minus 1 by n, right? Sin 2n pi is 0, see, sin 2n pi is 0, so 0 into anything is 0, so my second term will be 0, and here minus 2 into minus 1, that is 2, and cos 2n pi is 1, so 1 upon n cube. So this is the value for the upper limit, minus the value of the lower limit. Here pi minus 0, that is pi square, right? And cos 0 is 1, so minus 1 upon n. In second term, sin 0, if I put 0 in the place of x, sin 0 is 0, so plus 0, and again minus 2 into minus 1 is 2, and cos 0 is 1, so 1 upon n cube. Students, this is the main step for the solution of the example. Most of the students did the integration very easily, but they make the mistake when they apply the limits. So please be careful when you are applying the limits. Little mistake of plus or minus sign will give you the wrong answer. Okay, so be careful when you are applying the limits. So 1 upon 4 pi minus pi square, that is plus. So minus, and plus minus is minus. So minus pi square by n. This one is 2 upon n cube, right? Here minus minus plus. So plus pi square by n, and here plus minus is minus. So minus 2 upon n cube. So this both term will be cancelled, and the first and third will also cancel. So 1 upon 4 pi into 0. So our value of Bn is 0. Okay. So have you any doubt for the value of A0, An and Bn? Okay. So now we have to substitute our all three values in this formula, that is f of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx plus bn sin nx, right? Now what is the value of a0? The value of a0 is pi square by 6. Value of an is 1 upon n square, and the value of bn is 0. So this is pi square by 6. So 6 into 2, so 12. Summation n 1 to infinity. The value of an is 1 upon n square, right? Into cos nx. And this one is 0 into sin nx. It will be 0. So after simplification, pi square by 12 plus summation n 1 to infinity cos nx upon n square. And what is our function? Our function is pi minus x by 2 whole square, right? Pi minus x by 2 whole square. Our question is, we have to just find the Fourier series. We have to find the Fourier series for this function. Okay, so this is our Fourier series for the given function, our Fourier series in the form of summation. If you wish, you can also write your series in the form of 1, 2, 3 up to infinity. So cos x upon 1 square, cos 2x upon 2 square, cos 3x upon 3 square, up to so on. So both answer will be same. You keep your solution through this term or this term. Both answer are same. No need to further simplification, right? So students, today we did our Fourier series. In our previous lecture, in the first lecture, we did the introduction. In first lecture, we did the introduction of Fourier series, right? And we take very simple example, that is f of x is equal to x. In today's, this is our second lecture for the Fourier series. In today's lecture, we did f of x is equal to x square and pi minus x by 2 whole square, right? So these are the algebraic functions. These are the algebraic functions and these are the continuous in the interval 0 to 2 pi. Okay, so I will give one example for your own practice. So please write down the question. Find Fourier series of f of x is equal to pi minus x by 2 in the interval 0 to 2 pi. In the interval 0 to 2 pi. Okay. I will ask you answer from anyone in tomorrow's lecture. Okay. So this is for your own practice. Now, if any students have any doubt or any query, then they can ask me in the chat box or they raise your hand. Is there any doubt? Okay, answers are coming that they have no doubt. Okay, so, okay, thank you. Everything is clear. Thank you, students. So, show me the last slide. Okay. Okay, okay. So, students, in tomorrow's lecture, we will study. In tomorrow's lecture, we'll do the example of the Fourier series about the exponential functions. Okay, about exponential functions, and the limits are the same, that is 0 to 2 pi. So thank you very much for your very nice cooperation.